Now, welcome to the second document that we need to understand for API 570 examination. The second most important document for API 570 examination is API 574. API 574 is inspection practices for for piping system components. This document is inspection practices. It is a supplementary document for API 570 code. That means whatever conditions were laid down or whatever the requirements were laid down by API 570, some information is going to be given on this. So this is a very general document. Why this is important? Because when we have seen in weightage during the introduction section of this, we have seen that according to the weightage of the examination, almost 12 to 15% of examination questions arise from this API 574 inspection practices. So we'll be looking at this, but again, 14% or 15% of examination questions will be from this, but this is not a very extensive code. Obviously it is information heavy, but we need to understand that not all of the things we have to read, because some things are very general. Some things in the body of knowledge, the entire document is mentioned, but some things are very general information regarding piping systems, regarding what is the size of the various kinds of nominal pipe sizes, what are some tolerances for that piping systems, what are hoses, what are valves. All of these details are available there, which are very common. Okay, so this document is a code that is strongly linked to API 570 exam. In some areas contains some same information that appears in 570. So some areas will give you the same information that is in API 570. So that we might not need to focus on, because we have already seen this in API 570. API 574 is divided into 12 sections. So you have 12 sections for API 574. Out of this, not all of the 12 sections are important. Some are very small, some are very general information oriented. Some are more extensive, such as inspection systems and something like that, inspection procedures that we need to follow. And the entire document contains only one appendix. Okay, so the entire body is made up of 12 sections and it has one appendix at the end. It contains a large number of tables, figures, mainly sketches of the piping component, and a few tables about piping schedule and wall thicknesses. Now API 570 examination body of knowledge will tell you that entire document is very important. Obviously API 574 is seen as a general piping knowledge part of the API 570 examination. So generally a piping inspector should know all of these things that are laid down in API 574. Okay, API 574 is a heavily unbalanced code. Okay, so not all sections are that important. Some sections are more important than others. Few sections, particularly the section 10, which is going to be the inspection procedures, is going to be much more important. Okay, so the section 10 of this, the inspection procedure and practices, it is one of the most important section of this code. It is almost 15 pages, while most of the sections, that is 1, 2, 3, 4, 7, 8, 9, 11, are about one or two pages long. Not as important, but again, a piping inspector should at least know these things. Okay, so only way to approach this is going by section. So it is recommended that a person who is preparing for the API 570 examination should at least read this document once. But then again, some sections are going to be more important, some sections are not that important. Okay, so let's go ahead with the section 1. Section 1 is scope. We already know what the scope is. So this publication does not cover inspection of specialty items, including instrumentation, furnace tubulars and control valves. This is going to be a closely related document for API 570 examination, and this recommended practice describes the inspection practices for piping, tubing, valves and other control valves and fittings used in petroleum refineries and chemical plants. Common type of piping components, valve types, pipe joining methods, inspection planning process, inspection interval and techniques, and the types of records are described to aid the inspector in fulfilling their role in implementing 570. Okay, this means whenever we are doing actual inspection on a system, API 570 is going to be very important because that has to be in compliance. But whenever a situation arises where an inspector might get confused of what needs to do now, the recommendations are given in this practice to help the inspector to actually run the inspection. Okay. Section 2 is references. So what references are used to make this document? Section 3 is terms and definition. Obviously the terms and definition we already know. A person should just read this once. These are almost all typical. You already understand what is an alloy, what is a piping system and all of these things, but at least read it once so you'll get an understanding of what these are. Next is abbreviations. Obviously these are the abbreviations used in the entire code, so whenever you see an abbreviation that you don't understand, you can refer it to here. Okay. So section 4. Section 4 is going to be one of the most important things when we don't understand that what is a piping system, what is a valve, what is a fitting, how many types of fittings are there. All of these things are laid down in section 4. So section 4 can be seen as a very general information about the piping systems. So section 4, the most common carbon steel piping materials used in petrochemical industries are ASTM A53 and A53M and ASTM A106. Industry uses both seamless as well as electric resistance welded piping for the process piping. The piping of nominal size larger than 16 inches is usually made by rolling the plates to size and welding the seam. So you'll have a plate, you'll roll the plate, and on the long seam you'll be doing the welding operation. This is generally the manufacturing process for pipings that are greater than the nominal size of 16 inches. Centrifugally cast piping can be cast, then machined into desired shapes and thickness or desired thicknesses. Steel and alloy piping are manufactured to the standard dimension in the nominal pipe size, that is NPS, up to 48 inches. Pipe wall thickness are designated as pipe schedules in the NPS up to 36 inch. The traditional thickness designation, standard weight, extra strong, double extra strong, that is standard weight, that is standard, extra strong is XX, and double extra strong is double XS. Differ from the schedules are used for NPS up to 48. In all standard sizes, the outside diameter is nearly constant regardless of their thickness. The size refers to the approximately inside diameter of the standard pipe, a standard weight pipe for NPS equal to or less than 12 inches. The actual thickness of the seamless piping can vary from the nominal thickness by the manufacturer's tolerance of as much as 12.5%. That is the actual thickness. Whatever the actual thickness is, whatever the reference thickness is given, it can be plus minus 12.5%. Under the tolerance for welded piping is 0.01 inch, that is 0.25 mm. The cast piping has thickness tolerance of about 1 by 16 inch, that is 1.5 mm, and minus 0 inch, that is 0 mm, as specified in ASTM A53 and A53M. Consult the ASTM or equivalent ASME material specification to determine what tolerances are permitted for the specific material. Cast iron piping is generally used for non-hazardous service such as water. It is generally not recommended for using in pressurized hydrocarbon service because of its brittle nature. Standards and the sizes of the cast iron piping differ from those for welded and seamless piping. Next is FRP piping. FRP is fiber reinforced plastic. Non-metallic materials also have some limited use in the piping system in the hydrocarbon process industry. The term non-metallic has a broad definition, but in this section refers to FRP groups encompassed of general acronym like FRP and GRP. FRP is fiber reinforced plastic and GRP is glass reinforced plastic. Typical service application for FRP piping includes water service, process water, cooling medium, potable water, seaway, grey water, non-hazardous waste, non-hazardous drain, non-hazardous vents, chemical, water, ring mains, fire water deluge, and produced and ballast water. Okay, so basically water and non-toxic services are generally made up of FRP. Now this is the table that is given for different types of NPS pipes. So this this table is to be referred whenever we are seeing a piping system. We need to understand that what should be the OD, what should be the ID, what should be the thickness. All of these things will be given in this table. This table is given for NPS 1 by 8 to NPS 48. Sorry, NPS up to NPS 24 it is given. Next is piping tolerance permissible. So for A53, when the nominal pipe size is less than or equal to 1.5 inch, the diameter tolerance is plus 1 by 64 to minus 1 by 64. For pipes greater than NPS 1.5 inch, plus minus 1%. Okay. Same thing for different materials. The acceptable tolerance is minus 12.5%. Again, A124, the circumference, specified diameter, the acceptable tolerance of the plate standard. So basically the tolerances are given for all the thickness measurements that were given in the above table. Okay, just read this. You don't need to remember all of these things, because even if this is the case, even if they ask that what should be the nominal pipe size of what should be the thickness of the nominal pipe size of 1 or 1.5, then obviously you don't need to remember this. That will always be the part of open book examination, where you can refer this table and you can identify what should be the thickness and something like that. Okay. The design of these piping systems are largely dependent on the application. Many companies have developed their own specification that outlines material, quality, fabrication requirements and design factors. ASME B313 and Chapter 7 covers the design requirements for non-metallic piping. American Water Works Association, that is AWWA, is an organization that also provides the guidelines on FRP pipe design and testing. FRP materials require some understanding as to their manufacturer. This manufacturing technique will generate a different set of physical properties. Each resin system has a temperature limitation, and each joint system has its advantages and disadvantages. Qualification of bonders and jointers is as important for FRP fabrication as the qualification of welders for the metallic fabrication. FRP pipe can experience UV degradation over time if not adequately protected. By adding UV inhibitor in the resin will prevent the premature fiber blooming caused by UV radiation. Okay, so fiber reinforced plastic have a tendency of degrading because of the sunlight or UV light. So we'll need to have some adequate protection for preventing the UV damage on the FRP piping. Standardized FRP piping system, commonly called as commodity piping, are manufactured for variety of services and are sold as products with predetermined design, resin, corrosion barrier and structure. Next is SBP, that is small bore piping, secondary piping and auxiliary piping. Small bore piping can be used in primary process piping or as a nipple, secondary piping and auxiliary piping. Nipples are normally 6 inches or less in length and are most often used in vents in the piping high points and drains at the piping low points, and used to connect the auxiliary or secondary piping. Auxiliary piping is normally open to the service, but can be isolated from the primary process. Examples include flush line, instrument piping, analyzer piping, lubricant, seal oil piping for rotating equipment. Pipe linings. So linings are basically linings that are installed in the interior of the piping system. Linings can be metallic, non-metallic. This linings are generally used for corrosion protection or for the protection from the service fluid to degrade the material. So if there is any kind of service fluid that is going to degrade the material, a lining is installed so that can be protected. Generally API 652 is used for installing the internal linings on tanks and on piping as well. Internal lining can be incorporated into piping design to reduce corrosion, erosion and product contamination and the pipe metal temperatures. Metallic liners are installed in various ways such as cladding, weld overlay and strip lining. They may be separate strips or strips of metal fastened to the pipe by welding, referred to as strip lining. Next is tubing. Tubing is basically a pipe, a very small pipe that does not require, tubings are generally seamless, okay? So you don't have a welding operation to create a tubing. You generally have a bar stock that can be mandrelled inside, so you don't have a visible weld seam on it. So tubings are generally seamless, but it can be welded. Its stated size is actual OD rather than the NPS. ASTM B88 tubing, which is often used for steam tracing, is an exception in that the size designation is 1 by 8 inch, less than the actual OD. So there are some outliers also, but basically you just have to understand that the tubeless, generally the tubes are going to be seamless in nature. Obviously they can be welded also, but in most cases they are going to be seamless. Most cases they are going to be made up of not ferrous materials, but they are going to be made from some different materials. These are the mostly the cases, but obviously there are some outliers. There you'll always have some exceptions associated with it. Next is valves. Valves are basically flow control devices. Now we already know that there are various kinds of valves. You just need to understand that what kind of valves are there. You just need to understand, you need to able to recognize what kind of valves it is just by looking at the diagram. You don't need to draw them, so you don't need to remember the construction of this, but you just need to understand the operation, and you just need to see the valves image, and you should understand what kind of valve it is. So basic types of valves are gate, globe, plug, ball, diaphragm, butterfly, check, and slide valves. Valves body can be cast, forged, machined from a bar stock, or fabricated by welding a combination of more than two or more than two materials. Although many valves are manually operated, they can be equipped with electrical motors and gear operators or other power operators to accommodate for the large sizes or inaccessible location, or to permit actuation by instruments. Body thickness and other design data are given in API 594, 599, 600, 602, 603, 608, 609 and B16.34. Okay. Next is gate valve. This is a gate valve. This is the diagram of a gate valve. Just remember what is a gate valve. You'll understand it. So a gate valve consists of a body that contains a gate that interrupts the flow. So you have a gate. If you stop the gate, the flow will stop as well. Okay. This type of valve is normally used at a fully opened or a fully closed positions, and as such often can be called as a block valve, since it is not generally designated for regulating the fluid flow. Reduced ports gate valves are also very common and have a port opening that is smaller than the end openings. Reduced port valve should not be used as a block valve associated with pressure relieving devices or in erosive applications such as slurries or lines that are to be picked. Globe valves, which is commonly used to regulate fluid flow, consist of a valve body that contains a circular disc that moves parallel to the disc axis and contacts the seat. So this is globe valve. You have a disc here. So this disc travels and the fluid is stopped, or fluid is controlled. Plug valve consists of a tapered or a cylindrical plug fitted snugly into the corresponding shape of the seat in the valve body. Then you have ball valve. Ball valve is another, you have a ball inside, this ball flows in and out. If it covers the outlet, then your outlet closes. If it covers the inlet closes. If it's not actuated, then your fluid is going to run. A ball valve is another quarter turn valve similar to the plug valve, except that the plug in a ball valve is a spherical instead of a tapered or a cylindrical plug. So you basically have a ball there. So this is a ball valve. You have a ball inside. This ball will move around and your fluid can get controlled. Diaphragm valve will generally have a seat there. So diaphragm valve is a packless valve that contains a diaphragm made up of a flexible material that functions as both a closure and a seal. When the valve spindle is screwed down, it forces the flexible valve against the seat or a dam in the valve body and blocks the fluid flow. Butterfly valve consists of a disc mounted on a stem in the flow path within the valve body. The body is usually flanged and of a lug or a wafer type. 1/4 turn of the stem changes the valve from a fully closed to a completely open position. So this is basically a butterfly valve. Just have to understand that what are some diagrams of this valve. Just by looking at the valve, you should be able to understand what kind of valve it is. Okay. Check valves. Check valves are basically valves that are used to stop the backflow. So check valves is used to automatically prevent backflow. The most common types of check valves are swing, left piston, ball, spring-loaded wafer check valves. So all of these types of check valves, they are generally used to stop the backflow of the liquid. Slide valves. The slide valve is a specialized gate valve generally used in erosive or high temperature service. It consists of a flat plate that slide against the seat. The slide valve uses a fixed orifice and one or two solid slides that moves in the guides and creating a variable orifice that makes a valve suitable for throttling or blocking. So basically a slide valve will have a sliding operation. Okay. So these are all types of valves that are generally used. It's a very general information. You just need to understand what is a valve, how many types of valves are there. Just by looking at the diagram, you should be able to understand what kind of valve it is. Okay. Next is fittings. So fittings are basically small sections of a pipe that is used to change the direction of the flow or to allow the flow to be diverted or added to. The fittings can be made of n number of materials. You can have raw pipes that are welded to get the desired amount of fittings. It can be welded, it can be formed, it can be n number of things can be done to make these pipe fittings. Pipe fittings can be of various types also. You can also have FRP fitting. FRP fittings are manufactured by different processes. They can be made, FRP is basically fiber reinforced plastic. So plastic manufacturing processes will make these kinds of fittings also. So you can do injection molding, filament winding, contact molding are most common techniques to make FRP piping. Same criteria are used to accept the pipe that should be applied to the fittings. In particular, contact molded fittings should be inspected to ensure that they are manufactured to the same specification as the pipe. So these are different kinds of fitting. You have a 90-degree bend, a elbow, long radius elbow, 45-degree bend, T-joint, cross joint, Y-joint. These are flanged end fittings. These are wrought material fittings. So in this case, this is also 45, this is 90, this is T, this is a cap, this is a reducer section, this is an eccentric reducer section, and this is a cross section. Okay. Next is threaded fittings. So you have threads inside, and threading, basically threads will be installed and you can join these fittings with the help of thread instead of butt welding. You can also have socket welded fittings also, depending on what kind of fitting is required or what is mentioned in the diagram. Okay. Flanges. Flanges are basically equipments that will facilitate connections between two pipe fittings. Okay. Generally, ASME B16.5 covers the flanges of various material through NPS 24. ASME B16.47 covers steel flanges that ranges from NPS 26 to NPS 60. The flanges of cast fitting or valves are usually integral with the fitting or a valve body. FRP flanges are manufactured using the same methods as fittings. Contact molded flanges should be inspected for dimensions, drawback, and face flatness. The layers of reinforcement should extend onto the pipe in order to create the proper bond and hub reinforcement. Obviously, FRP flanges are FRP flanges. Okay, mostly we'll be using metallic flanges when we are talking about ABF 570, but in case of FRP services, FRP flanges would be used. Expansion joints, pipe supports, support design, general conditions. Just read this. These are not that important. Most important section in this code is going to be the inspection procedures and practices. Pipe support design, specific consideration should be taken. Pipe shoes, pipe sleeves, double plates, half soles, wear pads, dummy legs, supports on insulated pipes, accessibility, welding, anchors and restraints, flexible hoses. Flexible hoses are often used to transfer hydrocarbon and other process fluids on a temporary basis to facilitate turnaround activities and to transfer the process fluids products to the rail cars or tanker trucks for shipment. Pipe joining methods, we already know how pipes are joined. Either you can thread it or either you can weld it. Okay, threading is generally not done on a big diameter piping. The threading is generally considered on a pipe which are less than 2 inches in diameter. So the threaded joints are generally limited to auxiliary piping in non-critical services that has a nominal size of 2 inches or smaller. Threaded joints for NPS of 24 inches and smaller are standardized in B1.20.1. Welded joints are either butt welded or socket welded. Butt welded are going to be the bigger size, and socket welding are generally going to be typically NPS 2 or smaller. Butt welding connections are most commonly found in petrochemical industry. The ends of pipe fitting or valves are prepared, that is beveled, the angle is cut out on the metal, and aligned with the adequate root opening in accordance with ASME B16.25, and other end preparation that meets the welding procedure specification, that is WPS, permits the end to be joined by a fusion welding. Socket welding are made by inserting the end of the pipe into the recess in the fitting or valve and then fillet welding the joint. So something like this. So if you have a joint like this, you will be socketing it in and then a welding would be done. So this will be a socket joint. Socket joint is generally done on a small dia fitting, generally less than 2 inches. Welded branch connections, flange joints, cast iron pipe joints, tubing joints, special joints. All of these things you just have to read, don't need to remember all of these things. These are very general information. Non-metallic pipe joints, bell and spigot, taper, butt and wrap, flange to flange. All of these things were just the general informations that were needed for piping systems. What are these kinds of pipes? Are what are some fittings? What are some threads that are installed? What are some valves that are installed? All of these are general requirements that API 570 inspector should know. In the next video, we are going to go for a slightly important section that is going to be regarded to inspection. Why we are actually doing the inspection. Obviously, this is also going to be a general thing, because why we are doing the inspection, we already know this because there are several damage mechanisms associated with that. But we'll talk about this in a greater detail in the next video. Thank you.